This question appears simple, but we are going to find out in this video. In this video, we want to determine the current I1, I2, and I3 flowing in the circuit below. I1, I2, I3. And we are going to be applying KCL and KVL. In our previous videos, we've done some simple calculation and explained what KCL and KVL stand for. So if you want to refer to those videos before coming back to this one, feel free to do so. Otherwise, let's ride on. To solve this problem, the first thing we want to do is to assign our positive and negative signs to the battery sources. For the 12-volt battery, the longer line is the positive, shorter side negative. Similarly, this is the positive and negative for the 8-volt battery source. After doing that, we want to now put a direction of current flow in each of the loops. This is a loop and this is another loop. So we want to apply direction of current flow. Good enough, this question already specifies direction of the current. So we can assume direction of current flow in line with the direction of current given in the question. So for this loop, current is flowing clockwise, as you can see. It's flowing clockwise. So we say this is the direction of current flow for loop A. For this second loop, you can see current is flowing anti-clockwise. So we assume a direction of current flow for loop B in an anti-clockwise direction. Now that we've identified the direction of current flow, we are just going to apply signs to our resistors, positive and negative signs to each of the resistors. Current enters this 2 ohms resistor from the left. So it enters positive, it exits negative. For the 1 ohm resistor is going this way, it enters positive, it exits negative. For the 3 ohms resistor, it is top to down. It enters positive, it exits negative. Now we've assigned the signs to each of the components in the circuit. We can now go ahead to solve this problem. The first thing we want to do is to apply KCL to this node. So applying KCL at the node, which is this node here, the algebraic sum of current flowing into the node equal to 0. And the interpretation is that the sum of the currents entering into the node is equal to the current flowing out of the node. So I1 entering, I2 entering, I1 plus I2 will be equal to I3 exiting the node. Let's call that equation 1. From here, let's make either I1 or I2 subject of the formula. You can make any one you like subject of formula, but in this video, I'm making I1 subject of formula, and I1 will be equal to I3 minus I2. Let's call it equation 2. We are done with the KCL. Let's move to KVL. Let's apply KVL to loop A. If we apply KVL in loop A, we are just going to have the battery source 12 volts to be equal to the voltage drop across 2 ohms and the voltage drop across 3 ohms because the loop covers 2 ohms and 3 ohms. So if we apply KVL there, we have 12, the battery source, equal to 2 times the current I1 plus 3 times the current I3. Let's call this equation 3. Like I said before, if you don't understand KVL and KCL, you can refer to the previous videos I've done and get clarity on them. From equation 2, we said I1 is I3 minus I2, so we are just going to plug in the value of I1 into this equation 3. So if we put equation 2 into equation 3, we are going to get 12 equal to 2 into I3 minus I2 plus 3I1, plus 3I3. I3 minus I2 being equation 2. If we expand, we have 12 equals to 2I3 minus 2I2, opening up this bracket, plus 3I3. 3I3 plus 2I3 is 5I3, so we have 12 equal to negative 2I2 plus 5I3, and that gives us equation 4. Now we are done with loop A. Let's apply KVL to loop B. If we apply KVL in loop B, we are going to get the battery source 8 equal to the voltage drop across the 1 ohm resistor plus the voltage drop across the 3 ohms resistor because 1 and 3 are in loop B. So 8 will be equal to I2 plus 3I3. 1 times I2 gives us I2 plus 3 times I3 gives us I3. Let's call this equation 4. So you can see the similarity between equation 4. Okay, if we call this equation 5, you can see the similarity between equation 4 and equation 5. They are very straightforward pair of simultaneous linear equations. So we are just going to solve 4 and 5 together simultaneously. Let's move on to the next page. So we have 4, we have 5. Let's solve it simultaneously so that we can get the value of I2 and I3 from this simultaneous equation. We are going to use elimination method. To eliminate, we need to make any of these variables have the same absolute value of coefficients, right? So let's eliminate I2. To eliminate I2, we need to make sure that this place is 2 and this place is also 2. So to keep this place as 2, we can multiply equation 4 by 1. To keep this place as 2, we can multiply equation 2 by 2. So multiply equation, not equation 2, rather equation 4 by 1, equation 5 by 2. So for equation 4, we have 1 times 12 is 12, 1 times negative 2i2 is negative 2i2, plus 1 times 5i3 is 5i3. For equation 4, 2 times 8 gives you 16, 2 times I2 gives us 2i2, 2 times 3 gives us 6, so we have 6i3. So we have got 2 here and 2 here, so we can eliminate them. How does negative 2 and positive 2 eliminate each other? If you do negative 2 plus 2, you are going to get 0. So it means if we add equation 1, if we add both equations together, we are going to eliminate I2. 12 plus 16 gives us 28. Minus 2i2 plus 2i2 is 0, so that is gone. 5 plus 6 gives us 11, and we have I3. So to obtain I3, we divide both sides by 11, which means I3 is 2.55 ampere. So we've got the current I3 flowing through the 3 ohms resistor to be 2.55 ampere. To get I2, we can simply substitute the value of I3 into any of equations 4 or 5. But let's put it in equation 5. It appears simpler. So 8 will be equal to I2 plus 3 times 2.55 because I3 is 2.55. 3 times 2.55 gives us 7.65. To obtain I2, we subtract 7.65 from both sides of the equation, and I2 will become 8 minus 7.65 to give us 0.35 ampere. So that's the value for I2. The last one we want to calculate for is I1. Remember, I1 plus I2 is equal to I3. This is an error. This arrow is facing this direction. So if we recall that I1 plus I2 equal to I3, we can make I1 solve the formula by subtracting I2 from both sides of the equation, so that I1 will be equal to I3 minus I2. Putting in values, I1 will be equal to 2.55 for I3 minus 0.35 for I2, and that gives us 2.20 ampere. So we have successfully calculated the current I1, I2, and I3. As you can see, I1, I2, I3. This is the application of KVL and KCL. So you can see that the question is not very simple, but if you understand how to apply the laws, you are going to get it correctly. If you enjoyed this video, please like it, share it to your friends and learning colleagues, and do comment in the comment section. Follow our page if you've not done so, and if you are watching us from YouTube, do well to subscribe to our YouTube channel and keep on encouraging us at Knowledge Base. Once again, thank you for watching.